Welcome students to online classes of mathematics for class 9th. In this video we are going to study the chapter number 9, which is areas of parallelogram and the triangles of NCERT textbook. And this one is the session number 5 for this particular chapter. Here we will be looking at the remaining question of the exercise 9.3. Myself Deepak Gautam, TGT Mathematics in Kendriya Vidyalaya Sangathan. So let's start with the today's class. Since we have already done the first 10 questions of this exercise in the previous sessions, now in this session we are going to start with the question number 11. Now question number 11 is in figure 9.27 ABCDE is a pentagon. So we are given a pentagon which is A, B, C, D and E. So we are having this pentagon ABCD in which a line through B parallel to AC. So we have drawn a line through B which is parallel to AC. Which line is this one? Okay, line through B parallel to this AC meets DC produced at F. That means this side DC is produced till point F. So these two lines are meeting at point F. Okay, this DC is produced till point F and there is a line which is PF parallel to AC meeting each other at point F. Okay, here we are asked to show two things. First one is that the area of triangle ACB and ACF are equal. So we have the two triangles. First is triangle ABC, this one, and second one is triangle ACF. We have to prove that the area of these two triangles is equal, and after that we have to prove that the area of AEDF, that is area of AEDF, this figure, is equals to the area of the pentagon ABCDE. Okay, let's start its answer. Answer number 11. First we are going to write the given part. Given here is a pentagon ABCDE. Given is a pentagon. Pentagon means a polygon with 5 sides. So we are given a pentagon ABCDE in which we have this line BF parallel to AC, in which BF is parallel to AC. And we have to show two things. First one is that is to prove that the area of triangle ACB equals to area of triangle ACF. And secondly, we have to prove that the area of figure, that is area of figure AEDF is equals to area of pentagon ABCDE. Let's try its proof. Proof of part 1. Okay, here you can see here in this figure that you have to prove that the area of these two triangles equal. Now here you will notice that the two figure which are that is two triangle AFC, this one, and a triangle ABC. These are on the same base which is AC, and between the same parallel AC parallel to BF. Okay, so we'll write, since triangle first triangle is ACB, since triangles ACB and triangle ACF are on the same base, AC, and between the same parallel AC parallel to BF. Therefore, the area of triangle ACB will be equals to area of triangle ACF, and this is by the theorem 10.2, which says if two triangles are on the same base and between the same parallel, then the area of the two triangle is equal. So this is by theorem 9.2. okay, so that's the proof of part 1. Now let's see the proof of part 2. Here we are asked to prove that the area of figure AEDF is this one. AEDF is equals to the area of pentagon ABCDE. Okay, so we are going to start with what we have proved in the part 1. So we have, since area of triangle ACB is equals to area of triangle ACF. Okay, we have proved this above, so write proved in part 1. Okay, so we have already proved that the area of ACB is equals to ACF. Now you will notice that in triangle this ACB and this ACF, if we add the area of this region, we will get the figure AEDF and the pentagon ABCDE. So we are going to add the area of this AEDC on the both side in above equation. Okay, on adding area of figure AEDC on both sides in above equation, on both sides in above equation, we get, what we get is, let's add the area of this AEDC on the both side in the above equation. So we have on the left hand side we have area of triangle ACB plus area of triangle AEDC equals to, on the right hand side we have area of triangle ACF plus area of quadrilateral AEDC. Okay, now when you add this AEDC to ACB, okay, AEDC to this ACB, will get the area of the figure AEDF. Okay, of these two will be area of figure AEDF, and second one will be, when you add these two, you will get the pentagon, area of pentagon A, B, C, D and E. Okay, and this is what we were asked to prove in the part 2 of question number 11. Okay, so first we have proved that the area of the two triangles are equal because they are on the same base and between the same parallel. Then by adding the area of this figure AEDC on the both sides, what we get is, we get the required result, which is that area of figure AEDF is equals to area of pentagon ABCDE. Okay, so that's the answer of question number 11. Now moving to the next question, which is question number 12, which says, a villager Itwari has a plot of land of shape quadrilateral. So there is a villager whose name is Itwari. He has a plot of land which is in the shape of a quadrilateral. The Gram Panchayat of the village decided to take some portion of his plot. So there is a Gram Panchayat who they decided to take some portion of his plot and from one corner to construct a health center. So Gram Panchayat is now taking a portion of his land to construct a health center. Itwari agrees to the above proposal with the condition that he should be given equal amount of land in lieu of his land adjoining his plot, so that as to form a triangular plot. Okay, so initially the shape of the field or the land of the Itwari, the villager, is quadrilateral. Okay, a portion of his land is taken to construct a health center. He agrees on this proposal so that in return he will get a land which is adjoining his plot, so that the new shape of his plot will become triangular. Okay, so explain how this proposal will be implemented. Okay, so first we are going to draw its figure. So that's the figure for this question. As you can see, the villager earlier had the plot of land which is in the shape of a quadrilateral, which is A, B, C and D, and as this portion of his land is taken from him for constructing a health center, and in lieu of that this portion of the land is given to him. Okay, as you can see, the earlier shape of this figure is the quadrilateral, which is ABCD. Now the new shape of this his plot is triangle EBC. Okay, so what we have to prove here is that the area of his plot, which was earlier in the shape of a quadrilateral, is equals to the area of his new plot, which is in the shape of a triangle EBC. Okay, let's write the answer number 12. First you will write the given part. Let ABCD is a quadrilateral land in which this side BA is produced, in which BA is produced to a point is produced to meet DE parallel to AC. Okay, so what we did here is we have produced this BA to meet this DE which is parallel to AC. Okay, in this figure when you look, they may not look exactly parallel, but we have to extend this E till the point where these two lines will be parallel. Okay, that means we are given that AC is parallel to DE. Okay, this AC and DE are parallel. What we have to prove here is that the area of the earlier quadrilateral, that is ABCDE, is equals to the new shape of the line, which is the triangle BEC. That's what we have to prove here, that area of ABCD is equals to area of BEC. Okay, let's start this proof. So what we are going to do here is, you will see that as the area of the two triangle, that first triangle is EAC and triangle AEC and ADC. So we'll write, since the triangles, so we have two triangles. First is triangle EAC and DAC are on the same base. Same base here is AC, and between the same parallel AC and DE. Therefore the area of the two triangle will be equal. That is, therefore area of triangle EAC will be equals to area of triangle DAC. This is by the theorem 9.2, which says if two triangles are on the same base and between the same parallel, then the area of the two triangles will be equal. Okay, so let's name it equation number 1. Now what we have done here is we have proved that the area of triangle EAC and DAC are equal. Okay, so we have proved that the area of these two triangles are equal. Now in this triangle, what we're going to do is we'll add the area of the triangle ABC. Okay, so we'll write, on adding the area of triangle ABC on both sides in equation 1, we get, what we get is, on the left hand side we have area of triangle EAC plus we are going to add the area of ABC to this, and on the right hand side we have area of triangle DAC, and we are going to add the area of the triangle ABC. Okay, so when you add this EAC and ABC, you will see that this EAC and ABC will give us the triangle BEC, that is area of triangle BEC, and when you add these two, you will get the area of the quadrilateral ABCD. Okay, and this is what we were asked to prove, that the area of the two shape is equal. This is the earlier shape of the plot of land, which is a quadrilateral ABCD, and the new shape of the land is triangle BEC. Okay, so that's the answer of question number 12. Now let's move to the next question, which is question number 13. ABCD is a trapezium in with A is parallel to DC. So we have a trapezium in with the side AB is parallel to DC. There is a line parallel to AC intersect AB at X and BC at Y. We have to prove that the area of ADX is equals to ACY. Okay, so we are having a trapezium ABCD in which the side AB is parallel to DC, and we have a side which is parallel to AC, which and intersecting AB at X and BC at Y, and we have to prove that the area of these two triangles equal. So let's draw its figure first. So that's the figure for this question. So we have trapezium ABC in which this AB is parallel to DC, and we have this line XY which is parallel to AC, okay, which is cutting the AB at X and BC at Y, okay. We have to prove that the area of the triangle ADX, which is here, this one, is parallel to the area of triangle ACY, which is here. ACY is this one. So we have to prove that the area of these two triangles equal, okay. So let's start by its answer. Answer number 13. What is given to us here is, we're given a trapezium ABCD, a trapezium ABCD in which AB is parallel to DC, and we have a line XY parallel to AC, okay. We have this XY parallel to AC. What we have to prove here is area of triangle ADX is equals to area of triangle ACY, okay. That's what we have to prove. Let's start its proof now. So we are going to start with the two triangles which are the triangle AXC, this one, AXC, and the triangle AYC, this one, okay. As both the triangle are on the same base AC and between the same pillar AC parallel to XY, okay. So we'll write, since triangle ACX and triangle ACY are on the same base here is AC, and between same parallel AC parallel to XY, which is given in the question, okay. Therefore what we get is that the area of triangle ACX will be equals to area of triangle ACY, okay. So what we got is the area of triangle ACS equals to area of triangle ACY. Now what we are going to do is, now we are going to consider the two triangle which is AXT and AXC, this one, okay. So all right, also triangles ADX and triangle ACX are on the same base, same base for them is AX, and between the same parallel line for them is AB parallel to DEC, which is also given. Therefore the area of triangle ADX will be equals to area of triangle ACX, okay. This is by the theorem 9.2, which says two triangles which are on the same base and between the same parallel are equal in area. And similarly this was also for by theorem 9.2, okay. Let's name it equation number 1 and this as equation number 2, okay. So now from equation 1 and 2 what we get is this area of ACX is equals to ACY, and here area of ACS equals to ADX. That means the area of these two will also be equal, okay. So right from equation 1 and 2 we get, from equation 1 and equation 2 we get, what we get is the area of the triangle, since both are equals to this ACX, that means the other two triangle will also be equal in area, that is area of ADX will be equals to area of triangle AC5. Okay, and this is what we are asked to prove in the question number 13. Okay, now let's move to the next question, which is question number 14. It says in figure 9.28, AP is parallel to BQ. This AP is parallel to BQ is parallel to CR. That means the all three lines are parallel to each other. We have to prove that the area of AQC is equals to area of triangle PBR. So AQ is this one, AQC, this triangle is equals to the area of triangle PBR, which is this one. Okay, so we have to prove that the area of these two triangles equal. So let's start this proof. Answer number 14. Answer number 14. First we'll write the given part. Given here is we have three lines, which is AP parallel to BQ is parallel to CR. Okay, that's the only information given to us here, and we have to prove that the area of triangle AQC is equals to area of triangle PBR. Okay, so let's start this proof. First we're going to start with the two triangle, this triangle ABQ and triangle PBQ. As we know, they are on the same base BQ and between the same parallel AP parallel to BQ, so their areas will be equal. Okay, so we'll write since triangle ABQ and triangle PBQ are on the same base and between the same parallel their same base is BQ and between the same parallel AP and BQ. Therefore the area of the triangle ABQ will be equals to area of triangle PBQ. Okay, since they are on the triangle on the same base and between the same parallel. Okay, so let's name it equation number 1, and this is by the theorem 9.2. okay, in similar way, now what we're going to do is we will take these bottom triangles now, this triangle CBQ and triangle RBQ. Okay, again these two triangles on the same base BQ and between the same parallel BQ and CR, so their areas will also be equal. Okay, so we'll write similarly area of similarly triangle CBQ and triangle RBQ are on the same base. Same base for them is BQ and between the same parallel for them is BQ and CR. Therefore the area of triangle CBQ will be equals to area of triangle RBQ. Okay, let's name it equation number 2. So now what we are going to do is we will add the two equations, that is equation ABQ and equation 1 to the equation number 2, that is the area of triangle ABQ will be added to the area of triangle CBQ, and in similar way area of triangle PBQ will be added to the area of triangle RBQ. Okay, so we'll write on adding the two equation, on adding the two equation, adding the equation 1 and 2, we get what we get is we will add the respective side of the equation, that is area of triangle ABQ plus the area of triangle CBQ from equation number 1 and 2. On the other side we will write area of triangle PBQ plus area of triangle RBQ. Okay, when you add these two, we'll get the result as the area of triangle AQC equals to area of triangle PBR, and this is what we were asked to prove in the question number 14. Okay, so that's the answer number of question 14. Now let's move to the question number 15. Here we have the diagonal AC and BD of quadrilateral ABCD intersect at O. So we have a quadrilateral ABCD whose diagonal AC and BD are intersecting at O in such a way that AOD is equals to area of AOD is equals to area of BOC. We have to prove that ABCD is a trapezium. Okay, we are given that ABCD is a quadrilateral. We have to prove that the ABCD is a trapezium. Okay, so let's first draw its figure. So that's its figure. Here we have a quadrilateral ABCD in which the area of the triangle AOD is given through the area of triangle BOC. Okay, and we have to prove that this ABCD is a trapezium. Okay, so let's start by writing the given first. Answer number 15. So first we'll write the given. Given here is a quadrilateral ABCD, a quadrilateral ABCD in which diagonals AC and BD intersects at O. Okay, such that the area of triangle AOD is equals to area of triangle BOC. Okay, this is what given to us. To prove here is that ABCD is a trapezium. ABCD is a trapezium. Okay, let's start its proof. Its proof will be, what we are going to do is we will prove that the area of these two triangles ADC and BDC are equal. Okay, and since they are on the same base, then they must be lying between the same parallel. Okay, which means that this pair of opposite side is parallel, hence this ABCD will be a trapezium. Okay, so we are going to start with, right, since area of triangle AOD is equals to area of triangle BOC, which is given in the question. This is given. Okay, on adding, we are going to add the area of this triangle on the both side in, let's name it equation number 1. Okay, so write on adding the area of triangle DOC on both sides in equation 1, we get, what we get is, we have this area of triangle AOD and we are adding the area of triangle DOC. Okay, on the other side we have area of triangle BOC and we are adding the area of triangle DOC. Okay, so we are adding the area of same triangle on the both sides. That means the equation will be still be balanced. Okay, so after adding AOD and DOC, we'll get the area of triangle. Okay, this AOD and DOC will give us area of triangle ADC. Okay, this will result into area of triangle ADC. On the other side, after adding BOC and DOC, we'll get area of triangle BDC. Area of triangle BDC. Okay, since triangle ADC and triangle BDC are on the same base for them is DC, and having equal area, therefore they must be lying between the same parallel. Therefore they must be lying between the same parallels. Okay, that is AB is parallel to DC, and this is by the theorem 10.9.3, which says if two triangles have equal area and are on the same base, then they must be between the same parallel. Okay, so we have the two triangles which are having equal area and having a same base, which is DC, so they must be lying between the same parallel, that is AB is parallel to DC. Hence what we got is that this one pair of opposite side of this quadrilateral is parallel, so therefore this will be a trapezium. Okay, so I'll write hence ABCD is a trapezium. Okay, so that's our answer. This is what we have to prove, that ABCD is a trapezium. By proving one pair of opposite side parallel, we have proved that ABCD is a trapezium. Okay, now let's move to the next question. Question number 16 is, in figure 9.29, area of a triangle DRC is equals to area of triangle DPC. That means the area of triangle DRC is equals to area of triangle DPC. Okay, and we are further given that the area of triangle BDP is equals to area of triangle ARC. That is area of triangle BDP is equals to area of triangle ARC. Okay, and we have to prove that the quadrilateral ABCD and DCPR are trapezium. Okay, so in order to prove that these two are the trapezium, we have to prove that the one pair of opposite side in each quadrilateral is parallel. Okay, hence they will be a trapezium. Okay, so in ABCD we are going to prove that this AB is parallel to DC, and in DCPR we are going to prove that this DC is parallel to RP. Okay, hence they will be the trapezium. So let's start with its answer. This answer number 16. We'll start with the given. Given here is that the area of triangle DRC is equals to area of triangle DPC, and we are given that area of triangle BDP is equals to area of triangle ARC. Okay, what we have to prove here is to prove that the ABCD and DCPR are trapezium. Okay, so let's start this proof now. So what we are going to do first is we will prove, since we have that the area of these two triangle is equal, that is these triangle area of these two triangle is equal, also they are on the same base DC. Okay, so therefore they must be lying between the same parallel, DC parallel to RP. Okay, so let's write So first we are going to start with the triangle DRC and triangle DPC. So right, since triangle DRC and triangle DPC are on the same base, their same base is DC, having same area, equal area, therefore they must be lying between the same parallel. Therefore this DC has to be parallel to RP. Okay, hence the first one, that is DCPR, is a trapezium. Okay, since we have the area of these two triangles are equal and they are on the same base, that means they has to be lying between the same parallel. This is by the theorem 9.3, okay, which says if two triangles are having equal area and are on the same base, then they has to be lying between the same parallel. So therefore these two sides has to be parallel, and which gives that DCPR is a trapezium. Okay, now we have to prove that this ABCD is also a trapezium. For that, what we are going to do is, well, right, what we have here is that we are given in the question that area of BDP is equals to area of ARC. Let's name it equation number 1, and we have this is given. Okay, and we also have that the area of triangle DRC is equals to area of triangle DPC. Okay, let's name it equation number 2. This is also given to us in the question. Okay, so now what we are going to do is we'll subtract this DRC and DPC from equation number 1, BDP and ARC. Okay, so we will write on subtracting equation 1, so equation 2 from equation 1 we get, okay, let's write this first. The first we'll write area of triangle BDP minus area of triangle DPC. Okay, the triangle on the side of this triangle. Okay, on the other side we'll write the area of triangle ARC minus area of triangle DRC. Okay, when we subtract the two, we will get this BDP minus DPC will get the area of triangle BDC. Okay, on the other side when we subtract, we'll get the area of triangle ADC. Now again, what we got is that the area of these two triangles are equal and they are on the same base DC. Okay, so we'll write since area of triangles BDC and ADC are equal and they are on the same base. Same base here is DC. Therefore this AB has to be parallel to DC. This is by the theorem 10.9.3. okay, hence ABCD is a trapezium. Okay, since we have proved that the one pair of its opposite side is parallel, so this ABCD will also be a trapezium. Okay, earlier we had proved that the one pair of opposite side DC is parallel to RP, so that this DCPR was trapezium. Okay, so that's the answer to the question number 16 of exercise 9.3. With this we have completed all the 16 questions of exercise 9.3 and the chapter 9. Okay, now you have to practice all the questions multiple times so that you understand them better. Okay, so that's all for now. Thanks for joining here everyone. Thank you.